Well, there's always something to do on quarantine, and I pimp out my services to just about anything because I'm I guess a mechanic whore. I like working on just about anything that's broke down that needs fixed. And today, this little beauty right here is just not working. I went in there and I started up the American Standard furnace, checked the thermostat, changed the filter. You can see it's a little bit dirty. Then I went ahead and checked the breaker and everything. Breaker's on. So next thing to do is check the disconnect right here and see if we got power going to this, and then we'll be checking this. 0315, the on, this one's off. The little nub right there will cover off. So see that, you know, whenever it's flipped off, you'll have off right here, and it will essentially cover where it says off at. So it's definitely turned on. And we're going to stick our Fluke Meter, which is on AC volts right there. We're going to use this screw right here for the ground. We're going to come over here and we're going to test our power, 120. Now we check the other. The other one's also got 120 on it. So the power is coming in for the quick disconnect here. So we're going to put that in and move over to the actual unit. Right, I went and got some tools out of the service truck here. Well, most of the time it's going to be in this panel right here. You're going to have the capacitor. It's going to go bad. That's what we're going to get ready to pull off here. It's really easy on these units, on these side bolts here. You just pull them off. You can test for power right there. Test the capacitor right there. All you need is a little 1/4-inch drive ratchet and a 5/16 socket. If those are loosened, you just pull that cover right off of there, and right here is going to be your capacitor. Now, the power's on. Make sure you don't touch anything, which is safety first. You should know not to touch anything. But this is what you're going to be testing out right here, is this capacitor. These types of units, you're going to want to start pulling this stuff off here and check it. You can check it while it is hooked up right here, just so you don't go through the hassle of pulling all this stuff off here and then having to put it back. But before you do that, you got to take the power off of it. Now you can check to make sure power's coming in here before you do that. Then go pull that quick disconnect. Right here's where your power is going to be coming in at. You're going to have the brown coming out here on this particular cable, which runs to the ground wire, so it's grounded. And then you've got the white and the black. You just got to follow them up here, and the white hooks in to this wire nut, which is the brown and red stripe, and then the black hooks into the black, which should come up right here and go right here. And then this one's going to be your neutral, so you should have hot neutral right there. It leads through the top half, which leads through to the capacitor, so you'd have to check what's coming in to this actual unit. Now you'll definitely need 2 hands for this, which you'll have to take one lead to the ground here and then one lead up here to see where your voltage is coming in at, which is going to be that red wire right there in the back. And just to show you, this does have power going to it. So now it's time to pull a disconnect. And to do that, all you need to do is pull this thing completely out, and it'll break that current, because the voltage will come in from the top down through the bottom on this one. You'll want to make sure by going back and rechecking the voltage on the actual capacitor again. And if you don't have a quick disconnect, you got to go in and find the breaker and flip that breaker and come out here and try the same thing. Make sure there's no power coming to this before you touch it, because this will basically be the easiest way for people to service these units when you're not home, to come pull this disconnect. And it don't have power coming to it. So now we can safely pull these wires off here and check this capacitor. Like I said, this is something you can check in place if you know what you're looking at, but it would be easier if I pull this off of here to show you all what you're going to be looking at. So we're going to be doing that right now. On this one, you're going to take this U-clamp off here. It's just got one screw right here in place. You're going to take that off there and then pull that cage right off here, pull your capacitor right out. Okay. Twisting it off here. Once I loosen this up, the other fastener is right there on the inside, but you can pull it right around this if need be. Get yourself a good diagram position, how these are positioned. All right, you got these set up like the triangle. Document which one of these wires plugs into what. Make sure to separate them. Take a picture of it with your phone, whatever you got to do if you're doing this for the first time. That way you get these hooked back up right. You don't want to just pull these off with your finger. You want to get yourself a pair of long nose, needle nose pliers here, and then pull them off right above the stem right there. That way you don't damage these, and whenever you reinsert the new capacitor, everything's going to be hooked up correctly. Here is what it's going to look like. Most of these should have indicators on them, and it should say fan, so it lets you know which one is the fan terminal. It should have a C for common and herm, usually for hermetically sealed compressor, which means that's what powers your compressor. Then you got the fan, then you got the common. This one does not have any of those indicators. So in that instance, you might have to Google something to see what you're looking at. All you got to do is go down here to find out information on your capacitor. You want to verify the value of the capacitor itself, such as on this one you can see where it says 45 plus 5, and then it's got 440 VAC. The 45 stands for the compressor side, and the 5 stands for the outdoor fan motor itself. Now, a lot of these will have a MDF on it, which stands for the microfarad. If you got yourself a voltage meter, if you're in the HVAC field, you can generally get a specific meter made to test these with that measures capacitance. I believe there's one meter called Field Piece that makes one. It's for HVAC technicians, and you know, it's got a MFD setting that you can run it to, but you can test these with a regular old meter on ohms. Also on these, generally, whenever they go bad, if you pull them off here, you might see that these have leaked somewhere because they have swollen. Usually if they swell up, they'll bubble up on the side, or they'll have a big dome-shaped type bubble right here up top if they go bad. This one doesn't seem to indicate any of that. And most of the time on these, you're going to have, if you're looking at this triangle shape, the one facing you is going to be the fan, this one's going to be the common, this one's going to be the herm. So we're going to hook up our ohms meter and test this one out. Putting it on ohms right here, and if it's got a good connection anywhere in this, then it will spike up in numbers and it will shoot right back down real quick, and it'll let you know that really fast. It'll shoot up in numbers and go back down if it's good. If any of these cells here are bad, it will not do anything at all. Went and picked us up a new one right here. Motor run capacitor 45 to 5. Pull her out of the box here. Now on this one you can see right there underneath it says fan. On this one you got C, and on this one you have got herm. Makes it a lot easier to test out. And the same concept will apply on these whenever you test these out and you get on the different ones, such as the fan. It should read right around the 5 range. And if you're testing out on the herm, it should read around the 45 range down into the 30s. It shouldn't be anything below that, or it'll tell you that that particular cell in this is bad. Then you can pull out your little diagram, make sure everything is wired the way it was when it come off. Now, as you can see, this one was smaller than the other one, so we did put a little bit of insulation right around it here. We got it fastened back down. Now we're going to try it out. Put this back in here. And it works. Okay, so I thought we was done. Everything was going good, and then all of a sudden it quit working all over again. And I have already retested the capacitor. The capacitor's running fine, but what the problem is this right here. This is a contactor. Now what you want to do with a contactor is to test the volts on it first. And if you have manuals that usually come inside of the doors on these, if they're newer units, they will give you diagrams and tell you basically what it looks like. As you can see right here, this is the single pole contactor right there on the left, and it shows you where the leads come in, lead 1, lead 2, and then you got T1, T2. Right there on the sides is the contactor coils that should have 24 volts AC, which is generally about 27 volts coming to it. Now to test that, you go to each corner of the leg right here, and if it's got volts coming to it, as you can see right there, it's got 28 volts. And then the one on this side we tested also, and it's got 28 volts. That means that it is getting the power that it is supposed to get, but this is not pulling in. It is supposed to pull in and enable it to run. If you push it in, it'll come on, but it is supposed to be holding in. Because that it's not, there's a really good possibility that the contact points inside there is burned up and they're bad, and this is going to need replaced. So at this point, I did go buy a brand new contactor. I simply took it out put the other one in, hooked everything back up, and now the fan is fixed. Hopefully this process will help some of you all out there make some basic repairs. Ever since this pandemic started, I've been taking on all kinds of different tradesman jobs, and they are jobs that people do need to know more about. They're jobs that will always keep you working, always keep you busy, and save you a whole lot of money if you decide to do it yourself. You're interested in that kind of stuff, pop the clutch on that subscribe button, go over to Instagram, hit follow, check out the new Facebook page. Otherwise, I just want to encourage everyone to go grab yourself some tools and make being a tradesman great again. I also like to do a shout out. If you like this type of work, go over and check out Dewey Did It's YouTube channel. He's got a lot of stuff going on. Check him out. You might like what he's got.